Good morning, dear student. In the last video, we have seen about the positive R effect, right? Where the electrons are released at the benzene ring. That means electrons are given to the benzene ring. Clear? And then, what is the minus R effect? Minus R effect in which electrons will be withdrawn from the benzene ring. And as the electrons will be withdrawn, that means taken away from the benzene ring, so it is called minus R effect, right? And now let us today see the example of the minus R effect, right? In yesterday's we have seen, see here, I will help you first to recall the plus R effect. You can see here, this is the electron pair given here. At the same time, when this will be the double bond, so this electron bond will be given to the benzene ring, right? So this electron pair will exist as the bond. So here it will be double bond and it will acquire positive charge. And here this bond will be shifted further and it will acquire negative charge, right? So the bond is given, so the electron is given, the bond is formed. At the same time, the bond is shifting to the other carbon by acquiring negative charge on the benzene ring. And you see, it is in the same direction is going here. See here, negative charge is acquired here, it is double bond here. Now this negative charge will be attacking here, and at the same time, simultaneously in the same direction, the bond is attacking to the next carbon, right? So this is the plus R effect. That means it is given, electrons are given to the benzene ring. Now here in minus R effect, electrons are taken away from the benzene ring. So I have recalled first for you it, and now see here it is the nitro group, nitrobenzene. Benzene ring and anode is attached to it. See here the bond is breaking here and the pair of electron is given to the oxygen. And here this bond is releasing from the benzene. That means it is withdrawing this electron from the benzene and giving it to the substituent, right? So what happens here? Here the oxygen with two lone pairs will now get one more lone pair, and here instead of one bond it will acquire now double bond. See the structure here. Already here three lone pairs, negative charge there. Now here one bond was cleaved, that means broken, and two electrons is now on this oxygen. This bond has given its electron pair, and here we see the double bond. So what happened over here? This complete electron pair is donated. It is released. It is withdrawn from the benzene ring. So this carbon will acquire positive charge because electron is donated. And now see what takes place. In plus R effect, both takes place simultaneously in the similar direction. But here it will be opposite. This bond will now give rise to the shifting here, and simultaneously this will not go here. It will be in the opposite direction and it will come over here, right? Because here it will shift here. So this will be bond and these two won't be together. This electron now will acquire a position over here. So this is the positive charge and bond is taking place. Now this bond will shift over here because this positive charge will now attract over here. So you see they will leave this and they will attract over here. So this bond is shifted here now, and this positive charge will be here. So here also the position is ortho, para, and again ortho. In this effect, we have to keep in mind that plus charge and negative charge is already there, because nitrogen has to satisfy its valency, right? 1, 2, 3 and 4. So still it has donated one more electron, so positive charge will be here, and here, yes, more than 2 lone pairs are there on the oxygen, it will acquire negative charge. This also we have discussed. So this 2 will be there, and still more cleavage took place. Here now one more electron pair is accepted, so it will be negative, and here the bond is already given from this carbon-carbon adjacent position. So bond is given to this, and that is why it will also acquire positive charge, because donation has taken place. So we have to take care that the number of negative and the number of positive charge should be equal here. So positive, positive, negative, negative, positive, positive, negative, negative. If 2 negative, 1 positive is shown, or 1 positive, 1 negative and 2 positive is shown, then also your structure will be considered wrong. Now what happened? This bond is shifting over here. So this carbon and this carbon is now donating their electron. So the positive charge will be there. We have learned this, that on donation of the electron, the positive charge is acquired. So this bond is shifting. That means they are giving their electrons. So positive charge will go and jump on them. So everywhere it has taken place like this. And so here what happened? This is the positive charge here, right? This bond shifted over here. This bond shifted over here. And now what will happen? Again here 2 bonds. So at last the resonating has taken place, and this one bond will cleave and give complete pair of electron back to the benzene. And so this electron pair at the same time will be given back to the oxygen, and we will get the same original structure with shifting of the bonds. Here now what will happen? This double bond will cleave, right? Breaking of the bond will take place. Here shifting of the bond. Here breaking is not taking place, shifting. So this one complete bond is shifted over here, and we can see it over here, right? So now no positive charge over here. Here positive charge is already there, right? Because shifting of the bond is taking, that means electron is donated, and here this electron pair is shifted between N and O. So again double bond is there. So 2 lone pairs, no need to put any negative sign, right? Electron is donated, pair is donated, so no negative sign. And here already negative sign, because there are 1, 2, 3, 4, 5, 6 pairs, that 6 electrons, or we can say 3 pair of electron. What happened here? And double bond O and single bond O, NO2 is substituent as it is, but shifting of the bonds took place. See, here the double bond was on right hand side, and this 2 slant and vertical over on the left hand side. Here the vertical is on the right and slanting is on the left. That means during this nitrobenzene formation, the canonical 3 forms takes place for our understanding on the paper, whereas spectroscopically these pi bonds keeps on shifting continuously, and due to that we are getting the shift into the double bond, that is the pi bonds. Clear? So this is about the minus R effect, where electrons are drawn from benzene ring to the substituent. So here positive charge in 1, 2 and 3 resonance structures are at ortho, para and ortho position, ortho, para and ortho position respectively. Thus, on nitro compound, nitrobenzene. So, thus on nitro compound, if any negatively, see here all are positive, positive, positive. So, if any negative reagent attacks, where they will take place? They will definitely attract to the opposite charge. They are negative, so they will go to positive. So, if any negatively charged reagent will attack, they will definitely go to ortho and para position. But if positively charged will attack, then they will repel. So they will not go on orthopara, but they will attack on either this meta or this meta position. So if positively charged reagent attacks, it will be on meta position. Why? Because on meta position, no positive charge is present. Thus, the species which directs the incoming reagents on the meta position, those species are termed as meta-directing groups. Species, that means the substituents present on the benzene ring. Those substituents which are present on the benzene ring, and when they are giving a path, when they are giving an idea to the incoming reagent, whatever the reagent is attacking to that benzene ring, to that reagent, the attached substituent when show the path and ask them to sit on the meta seat, then those attached substituent or species are termed as meta guiding or meta directing groups, right? So here nitro groups, then aldehyde group, carboxylic group, they are all meta directing group. And in the last video what we have seen for positive effect, they are all alcohol, halogen, amine. They have tendency to release and they are directing the attacking substituents on ortho and para position. So they are ortho para directing groups. Clear? So this was about the resonance effect. Resonance positive, resonance negative. Now we'll see the fourth effect, and that is the hyperconjugation effect. Hyperconjugation is also a concept which is like resonance, but here bonding is not present. In resonance, we have seen the shifting of bond takes place continuously, and that's why the intermediates we see as a canonical structures. But in hyperconjugation, resonance takes place, but bonding is not present. It means from where an electron shifts between it and carbon, there remain a gap. What is here given? Bonding is not present. It means from wherever an electron shifts between it that means the position from where the electron is shifting, and carbon, between those two carbons or the element and a carbon, there remains a gap. Gap remains over there and bond is not present. So it is also called no bond resonance because bond is not present. It exists where where this no bond resonance takes place, right? Shifting of the bonds between two carbon atoms or a carbon and an element takes place. But during this shifting, there will remain a gap. Empty space will remain there and bond will not be formed. Whereas that particular molecule will not leave the molecular compound also. So where this thing takes place? So we can say it exists where one double bond and one single bond are present adjacent to each other. When one double bond and one single bond are adjacent that means side to side. One here, then the next here. Side to side, when they are present, it is called adjacent position. So, What is conjugation now? Conjugation means to make forcibly one double bond system in the compound during the reaction mechanism. So conjugation is a process in which one double bond system is made forcibly, right? Let us see example. Here it is CH3, CH, double bond CH2. Now see here, this is single bond, single bond. So in this two, it will not take place. But this is single and this is double, adjacent to each other. That means the shifting will take place on these two. So here the forcibly, that means this is single bond. So now we have to make this double. In reaction it takes place in that manner. So here on pen paper we have to make it double, and that will be the conjugation. So what happens? This hydrogen will release the electrons over here, and this complete pair will be here. Where it exists at adjacent single and adjacent double. So this bond, the electron pair, is shifted over here. So now this will be this double bond, right? And at the same time, simultaneously, this electron will be shifted to this carbon. Now this electron will shift to carbon. So valency of carbon will not be satisfied because it will be 1. Then CH2, and this will be 3. So still one more bond needed. That is why this hydrogen will give both the electron and the bond will take place. And so here will be the double bond. Right? Now this double bond will take place, but here now no one is there, no lone electron. Carbon and hydrogen has shared electron, which is completely shared here. So now there is no electron, and the electron which was with the hydrogen is now completely shared, given, so it will acquire positive charge. And here this double bond is shifting on the carbon as an electron pair. So they are accepting electron pair, so it will get negative charge. Here this double bond which is formed is conjugation, because double bond is possibly formed at the adjacent atom by the entry of the electrons. It was not there, but because of the entry of the electrons, it has taken place. And what about this hydrogen? Here the hydrogen atom will not leave the molecular compound. It will not leave this compound, but it will remain there, and one by one they will rotate the electron and will give the double bond either sides. And this is considered as hyperconjugation, because not only one by one, after this hydrogen, this will also take a chance, this will also take a chance, and that is called hyperconjugation. That means all one by one will take part, or they will participate in the reaction, right? So here what is given? Here all 3 hydrogen atoms will participate one by one in the conjugation to make compound stable. So it is hyperconjugation, right? See here how it takes place. Once again, a whole resonance I have shown here. CH3, CH, double bond CH. This electron pair of a bond will be shifted to this carbon. So to satisfy the valency of carbon, because if this complete pair is shifted here, so what will be for satisfaction of this carbon? See, CH, one bond, here only now one bond will be there. So 1, 2 and 3. But actually carbon should satisfy 4 valency. So these hydrogen will share complete electron pair over here. So here double bond will take place. Now this hydrogen will acquire positive charge, and here no bond is present, so it is conjugation, and this will acquire negative charge. Now what happens? This hydrogen here negative, and it is acquired 2 charge. Now this bond is replaced to this hydrogen, and this hydrogen will take positive charge. At the same time, this hydrogen will now shift the bond here and it will acquire the positive charge, right? So all three hydrogen one by one participate in the conjugation and there exists hyperconjugation. It is said that more the hydrogen, as many number of hydrogens are there in organic compound, right? That stability, that means that much stability is for the compound. So more the hydrogen, stability will increase. Here in propene 1 in 1, 2, 3, 4, 5, 6 hydrogen, right? So as many hydrogen, accordingly the stability increases. It is the interaction. Now from this discussion of the example, we can also explain conjugation that it is the interaction between the electrons of pi system and sigma bonds. Interaction between the electrons. This is pi because double bond and this is sigma because single bond. So the interaction between the electrons of the pi system and the sigma system of the adjacent substituent in organic compound. Of the adjacent substituent in an organic compound, which was studied and given by Baker-Nathan, and so this effect is also called Baker-Nathan in honor of his name, by his name in his honor, or even we can say it as a no bond resonance. So the effect also explains very well the alkyl related alkene compounds. Alkene compounds, that means those who are having double bond, and alkyl related, that means the attachments to alkene family are alkyl members. You can see here C double bond C, so alkene compound, and attachment you see CH3, 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 all methyl, that means alkyl family. Here we can see all attachment are 4 terminals and which have 3 hydrogen each. 3, 3, 3, 3. So total 12 hydrogen. That means on each side it is completely shared hydrogen atoms. That means I don't think now any more hydrogen can be attached here. Right? That means this is the most stable compound because more the number of hydrogen, more is the stability. So here 1, 2, right? 1, 2, 3, and accordingly here you see 1, 2, 3 hydrogen 4. 1, 2, 3, 4, right? And for this carbon 1, 2, 3, 4. For this carbon also 1, 2, 3, 4. So if we consider the IUPAC name, what can be the name? 1, 2, 3, 4. 4 carbon in a continuous chain, so it is a butane family. And now on second and third carbon, right? Or if we consider this 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. So on second and third, there is a methyl group attachment. So it will be not 2, 2, but it will be 2, 3. 1, 2, 3, 4. So 2 methyl, 3 methyl. 2, 3 dimethyl. Total 1, 2, 3, 4. But on second double bond, so ene. 2, 3 dimethyl butene. Here if one methyl group is less, suppose if one methyl group is replaced and only hydrogen is there, then what will happen? The stability of that particular compound will be less. So what we can say here, that this is CH3, right? I am writing it again. This is CH3, right? Double bond C, CH3, CH3. Now instead of this, what is said? Suppose if one methyl group is replaced. So now instead of this, here it is only H. This methyl is replaced. It means 3, 3, 3. 9 plus 1, 10. 2 hydrogen is less than this. Here 12 hydrogen. Here 2 hydrogen. 2 hydrogen less. That means only 10 hydrogen. So if we compare stability, then this will be the more stable compound. Clear? Now, let us see one more topic here, which is called bond fission. Fission, that means to break the bond, right? And fusion means to merge, to connect, to mix, right? So first of all, what is fission? Fission means breaking of bonds, and fission means breaking, and bond fission means breaking of bonds. And fusion means merging or mixing, and bond fusion means mixing or merging of bonds. So this bond fission are also of two types. When organic reaction takes place and when the formation of the reactant to product takes place, different types and a wide variety and range of organic compounds takes place, and it is because of the fission, which is also called cleavage, right? So there are two types of cleavage, there are two types of fission. Fission means to break, cleavage also means to break. So it is homolytic cleavage and heterolytic cleavage, or homolytic fission, heterolytic fission. Homo, the word gives us the idea about the compound that is having a similar atom, so that is homolytic, and different atoms, so heterolytic. When the breaking of bond takes place between the similar atom, then it is called homolytic fission. It means breaking of bond of similar atoms means homolytic. Now suppose here are these atoms which are similar and they are bind together with covalent bond, right? Then this covalent bond can undergo the fission process, and at this time we see that the bond can be fissed. That means breaking of bond takes place. On breaking, what happens? Then when both are similar atom takes place because of the covalent sharing electrons give access to covalent bond, and covalent bond is between the homoatomics. So this, on breaking the bond, both of them, or we can say both each, will get one electron back. These electrons both are not paired because now they are separated. So they are not paired and they are unpaired electrons, right? So due to the fission, the free radicals, these electrons, after breaking, when atoms acquire each in equal number, then they are called free radicals, right? Both each have free radicals. So unpaired electrons or free radicals are intermediates formed in the reaction because of homolytic fission, right? So what is here? Free radicals as an intermediate are formed in homolytic fission. And the next step of fission is heterolytic. Hetero, that means between different atoms. The breaking of bond between different atoms takes place, then it is heterolytic. And in heterolytic, the electrons won't be considered neutral and will be as a without charge, or we can say neutral radicals. But in homolytic, when both the atoms are different and when the bond breaks, one will share completely accept the electron pair. That means any one of the atom will completely grab the electrons, and on gaining the electrons will acquire negative charge, and the other partner which has already donated the electron, so it will now have positive charge. That means on donation of the electrons, after breaking, it will not accept any electron and will give both to the another atom. That means this becomes positive and it will be because in the organic compound. So it will be carbocation and accepting the negative ion. So it is carboanion. So what happened here? Here one species will take both electrons B and other will not have any on fission reaction. Then A without any electrons acquire positive charge because it has donated, and B has now excess because accepted both, and B with the excess electrons acquire negative charge, right? So here in reaction the intermediates which leaves the electrons, leaves that means give away, it is called positive charge and carbocation, and the species which acquires the negative charge because of the presence of two lone electron, then it is called carboanion, right? So as this, why we know that donation of the electron gives positive charge cation, exception of the electrons gives negative charge anion. But it is because in the organic compound, an organic compound is based or centerized to the carbon, so it is carbocation, carboanion. Thus, the formation of the free radicals in homolytic fission and formation of carbocation and anion in heterolytic fission, they are considered as the intermediates, and intermediates help in increase of the reactivity of the reaction to develop it in to or make it progress in forward rate, right? So please go through these topics, right, very calmly, and try to read and try to understand. Wherever you are not finding easy to understand, please feel free to contact me. Thank you.